y equals sine of x on the closed interval between 0 and pi. Let p, which equals separate values 0, pi by 4, pi by 2, 3 pi by 4 pi, be a regular partition of the closed interval between 0 and pi, so it's chopped up. You've got 5 points, which makes 4 strips. Calculate L4, the lower Riemann sum for 4 rectangles to approximate area, and U4, the upper Riemann sum to approximate the area using rectangles. That's the area under y equals sine x and above the x-axis. Right, and then we need to sketch the corresponding areas on graphs of the function. So what I'm going to do first is just sketch sine x between 0 and pi. Well, if I take this as 0 and this as pi, if I just draw a little unit circle, remember sine's the height, so sine 0 is 0, sine pi is also 0, sine pi by 2 is 1, the other ones we're interested in are pi by 4, sine pi by 4 is root 2 over 2, and sine 3 pi by 4 is also root 2 over 2. So that means it's going to pass through here and here at 0, 0. It's going to go up to 1, like that. If I just try and draw that, it's a bit steep, but never mind. Up to here and then down to here. And we've got pi by 2, we have pi by 4 here, and here we have 3 pi by 4. So we probably could do with some values on here. So I know f of pi by 4 we said was root 2 over 2. F of 3 pi by 4 is also root 2 over 2. F of 0, remember it's sine 0 equals 0. F of pi by 4 equals root 2 over 2. F of pi over 2 equals 1, and f of 3 pi by 4 is also root 2 over 2, and f of pi equals 0. Right, so there are values that we're going to use. Now for the Riemann sums, remember our sums are un or ln. Ln is, well, it's delta x. We've got a regular partition, so we can pull our delta x out. I'll talk about delta x, its value in a minute. Delta x times the sum from I equals 0 to n. In this case, n is 4 of, well, it's f of xi. You will sometimes see this asterisk. Basically, what it means, you can select whichever x makes the lowest value of f of xi within the subinterval, right? So you do need to think about this particular function, because it's not as simple as saying we're always going to pick the left-hand side ones or we're always going to pick the right-hand side, because what happens, this function gets bigger and then it gets smaller. So in any of these strips, if I just draw the lines, so we've got our four subintervals that we split it into, we're going to have to be very careful what we select. So the ln in this case, well, delta x is b minus a over n for a regular partition. B minus a over n, b is pi, a is 0, so it's pi minus 0 over n is 4, so it just equals pi by 4. So our ln equals pi by 4, that's your delta x, times the sum of the smallest heights. So if we take it subinterval by subinterval, and the first subinterval is from 0 to pi by 4, we're going to use f of 0, which is just 0. So because you've got two options, you can either use 0 or pi by 4, and clearly 0 is a lot smaller. It's significantly smaller. So we're going to use 0. Plus, now we look at the second interval, which goes from pi by 4 to pi by 2. So we can either use f of pi by 4, which would be root 2 over 2, which would be like that, or f of pi by 2. which would be 1. Clearly this one's bigger, we want the ln, so we're going to use root 2 over 2. Plus the next one is the subinterval between pi by 2 and 3 pi by 4, so we can either use this value here or this value. So we are going to use whatever makes it smallest, so clearly that's f of 3 pi by 4, which is root 2 over 2 again. Root 2 over 2, and then on to the final subinterval between 3 pi by 4 and pi, we are going to use f of pi, which is 0. So now we have pi by 4 plus, or 0 plus 0, plus root 2 over 2 plus root 2 over 2. So that's 2 root 2 over 2. So now we have pi by 4 times 0 plus 0 is 0. Then you've got root 2 over 2 plus root 2 over 2, which is just root 2. So then we end up with pi root 2 over 4 units squared. Right. For the upper Riemann sum, or I should have probably called that L4, for the upper Riemann sum using 4 strips, delta x is the same, and then we need to use whatever values of x make f of x the biggest, and then put that f of x in. So for the first subinterval, we're going to use f of pi by 4, which is root 2 over 2. It makes a big interval, a big rectangle like that, root 2 over 2. For the second subinterval, we can either use f of pi by 4 or f of pi by 2. Clearly f of pi by 2 is bigger, it's 1. Sine pi by 2 is 1, 1 plus. Now for the next interval, we're going to use f of pi by 2 again, it's an option. So we're going to do it like that, and that's 1 again. And for the final subinterval, we are going to use f of 3 pi by 4, which is root 2 over 2. So this is pi by 4 times root 2 plus root 2, sorry, root 2 over 2 plus root 2 over 2 is root 2 plus 2. So root 2 plus 2. And you could expand that, but I don't think it's going to look a lot better. So I think I'm just going to leave it like that, units squared. So then we've said the true area under this curve, we don't know what it is. Obviously we do have the tools to work it out, but we know that it's bigger than pi root 2 over 4, and it's smaller than pi over 4 times root 2 plus 2. I've already talked about the sketch, I'll just show them separately. So for our lower sketch, remember we had 0 and pi, and then we've got pi by 2, pi by 4, and 3 pi by 4. And then we've got our graph of sine x, which goes up to 1 here, something like that. Just move that, that can be 1 up there. And for the lower, well, we used this for the first one, there's no bar at all. Then we used f of pi by 4, which was that rectangle there. Then we used f of 3 pi by 4, which is that. And then we use 0 again, so that's your lower one. If we put some numbers on the x's, remember this was root 2 over 2, and the top of it is 1. Okay, so that's the lower. The upper, un, same graph. Up to 1, try and draw it better. Then we've got pi by 2, pi, 0, pi by 4, 3 pi by 4, there and there. And then we used this for the first bar, we used that area. Then we used 1 twice, so we used these bigger bars here. And then we used this, so you can see it's clearly a lot bigger. So that was our area for un. Put some values in. This is 1, this is root 2 over 2.